Ok, buenos días. Estamos acá en la presentación para el proyecto de tesis de Magister de Geofísica de Javiera, Álvarez, Vargas, y que también se conoce de su trabajo de HP. El proyecto se titula Interacción entre terremotos históricos en la brecha sísmica de Chile Central y la falla cortical Marga-Marga, la ordenanza sísmica de la región de Valparaiso. El comité de tesis está formado por la profesora Guía Ignacia, Calisto, el doctor Ignacia Calisto, del Departamento de Geofísica, el profesor co-guia, el doctor Jorge, Crempien, de la carrera, de la Pontificia Universidad Católica de Chile, el profesor doctor Joaquín Cortés, el doctor Profesora, el doctor Carlos Pachela, y yo actúo como representante del Magister de Física. Entonces, vamos a tener una presentación de 30 minutos, después de 30 minutos de la comisión, y después le vamos a pedir que se retiren para que la comisión delibere y se anuncie el resultado. Así que, adelante.
Okay. Esta presentación va a estar en inglés, así que espero comprender. So, first of all, I want to say thank you all of you for being here today. And today I'm going to present my thesis to obtain a degree in geophysics and also the thesis project of my master in geophysics. And this project is called the interaction between historical earthquakes in the seismic gap of Central Chile and the Marga-Marga crustal fault, the seismic potential of the Valparaiso region. A little resume about this presentation, but I go ahead with a little context about this research. So, Chile is located in one of the most active seismic zones of the world, and that is because of the subduction between the Nazca Plate under the South American Plate. These subductions produce, that you can see in figure 1, a seismogenic zone. But also we have another type of seismic events, like for example, the seismic event for the crustal faults. These crustal faults are under our feet, really nearly to the cities. So with all this catalog of large earthquakes in Chile, we can try to study the seismic cycle for the present and future, researching about the historical earthquakes in the past. So for this presentation, I'm going to study the historical Central Chile segment that you can see in figure 2. And in this figure, we are going to center in the rupture pattern from the historical earthquakes, like for example, the Central Chile of 2030, or more recently, Maule 2010. But I want to focus only in the segment of the Valparaiso region between the 33 and 34 Great South. And that is because this segment of the country has been in a seismic gap since like almost 300 years. So, of course, we have some seismicity, like, for example, Valparaiso 1906, or Algarrobo 1985, or more recently, Valparaiso 2017. But we don't have present a seismic earthquake with the characteristics of the magnitude and depth of the Central Chile. So we are expecting an earthquake like that for the future. And we can say that if you see the figure 3, is the coupling zone of the Valparaiso region. So for this figure, we take some GPS stations and nearly to the cities of Valparaiso and Viña del Mar. And we see some velocities major to 24 millimeters per year in the sampled velocity. But also you can see that the interseismic cycle is still in progress in the future, after the 2017 earthquake. So this is relevant for this study. And why it's relevant also because in this segment, specifically in the city of Viña del Mar, we have a crustal fault called the Marga-Marga fault, which is a fault located under the Marga-Marga estuary. This fault is a normal fault and bisects all the geological plan of Viña del Mar that you can see in figure 4. And this is important, this fault, because the thing that I want to research is the possible interactions between the Marga-Marga fault and the historical subduction earthquakes, because this happens before, for the Pichilemu seismic sequence for the event of Maule of 2010. That, if you can see here in figure 6, the Maule earthquake triggered this fault and also the Santa Maria fault, provocating earthquakes with magnitude of 6.9 and 7 of the normal faulting earthquakes. And you can say that, of course, the subduction earthquakes of the Maule 2010 was major with a magnitude of 8.8, but these crustal earthquakes are more capable to damage the localities because they are really nearly to the cities, for example. So, a little historical background about the events that I am going to study for this research are first the historical background for the 1730 earthquake that occurred in July 8 with a magnitude estimate of 9 to 9.3 with a large rupture that you can see in figure 7 from Copiapó to Concepción. The tsunami was major in all the coasts and the uplift was only in some segments of the cities. Also, the importance of this earthquake that some historical data and some research, like for example, Ruiz y Madariaga and Carvajal, says that this 1730 earthquake has a really shallow rupture. And this is important because with this shallow rupture, we can see a major tsunami in the coast of Copiapó to Concepción, right, in the figure 8. And we also can see the flooding of the nearly to the Viña del Mar coast and Valparaiso Valley. Another seismic earthquake that I are going to study is the 1906 event. These events occurred in August 16 with a magnitude estimated by 8.2. The rupture was a little minor from Illapel to Parral. You can see the rupture of the earthquake and that figure. I don't see the number. But the relevant in here is the depth of this earthquake and the uplift in all the coasts that you can see, and some deformation report of uplift in the coast, like for example in Constitución, Yico, Pichilemu, Cartagena to Los Vilos. And what is the connection between this historical earthquake and the Marga-Marga fault? Because we are trying to see the interactions between these historical earthquakes and the Marga-Marga fault. Well, if you can see the figure 10, you can see the projected Marga-Marga fault. And for localities of the city of Viña del Mar, the Población Vergara, Sugar Refinery, El Salto to Ferrocarril, and these four localities are very affected by this historical earthquake. And it's important because if you see the trace of the fault are really nearly to the damage to the localities. Also, according to Rosas and Cruzat, a deep fissure was observed from which turbulent water and sediment was spring to El Salto. But I think that the most important point to try to talk about possible reactivation of this fault is that in the segment of the El Salto to Ferrocarril, the railway tracks with a zigzag pattern. In that suggests that the soil has been shared by this horizontal movement of the fault. Finally, we are going to study the historical background of the 1985 event. That event occurred in March 3 with a magnitude of 8. The rupture was minor, if you can see the 1730 earthquake, right? And the tsunami was minor again, but the uplift in the coast was again important. So this talk about a deep earthquake that we want to study also for the interaction again with similar mechanisms that the 1906 event. So for this 1985, we see a significant structural damage on San Martin Avenue, really nearly to Población Vergara, and also the upward placements of deep sedimentary material studied by Thorson in El Salto. So if you can see, I really like a pattern taking in consideration the formation of the 1906 event. But also, we can see that it's important to observe the historical accelerograms that you can see in figure 40, related to the city of Viña del Mar, because Rogelio Torres see two arrivals in historical reconstruction of this 1985 event. So for this research, we are going to try to quantify the interaction between the Marga-Marga fault and this historical event, seeing the nearly field and the far field to see a possible interaction or reactivation of this fault. So, with all of context of this context, I'm going to present my hypothesis of this research. That is that the subduction earthquakes along the Valparaiso Gap have the potential to trigger moderate to large shallow seismic events on the overlying Marga-Marga fault. Due to its location near the cities of Valparaiso and Viña del Mar, an earthquake along the Marga-Marga fault could cause significant damage to the area. And the questions that make this hypothesis are fears that can subduction earthquakes on the Valparaiso segment trigger the Marga-Marga fault? And which historical events need to be investigated to prove the fault activity? And finally, how does the geology of the sector impact the interaction between the fault zone and the subduction megatron's earthquake? Because does the fault work as an exacerbating factor or as a protective barrier? So to try to research about this hypothesis, we have this archetype that is to assess the condition under which subduction earthquakes in the Valparaiso segment are more likely to trigger stress transmission to the Marga-Marga crustal fault. Doing FEARS, try to identify the slip distribution of historical tsunamigenic earthquakes in the segment of Central Chile, calculate the stress interaction between the Marga-Marga crustal fault and the historical seismic event, and finally try to model the stress interactions between these faults and the historical event to try to identify some patterns or influences to research these events. So, what are the methods that are going to use for this research to complete the objectives? Are first the historical earthquakes. And for this method, we are using the logic tree approach by Cifuentes Lobos. And if you can see the figure 15, I think I can see the number. We need to input a magnitude estimate of the event, but also a rupture in the northern limit and the southern limit. Also, in the figure 16, I think, it's important also input the distance to the trench in kilometers to a possible shallow earthquake or deep earthquake. Also, we need to input a number of subfaults along a strike and along deep, and to try to make an accurate aspect ratio, and also the number of slip models created for each parameter combination. And that is because this is a stochastic model. So with these stochastic models, we can have thousands of results. And what we are going to do with these thousands of results, we have to restrict them. First, we do in the random slip models of the logic tree approach, calculate the vertical deformation, and the restrictions go to the first, the data density, if the sliding path is located in the larger data of historical data deformation. If it's passed, we have to restrict during the coincidence slip and deformation. That says that if the maximum slip is coincide with the maximum deformation of the zone. And finally, we can restrict using qualitative and quantitative data using a coincidence and tolerance. And this shows us the qualitative data, that is the register, like for observation of the people registered in the historical documents. And the quantitative are the metrics in meters, for example, of the uplift or subsidence of the zone. After that, we can try to restrict using the tsunami models. And for this, we are going to try to respond to this question, that is, there are matches of model tsunami headed in the data if the arrival of the tsunami is accurate with the deformation data of the historical documents. So if we are not more regions in models, we can start up the model analysis, right? But I say that this is a stochastic model. So of course we have some errors. And these uncertainties are associated with fears, the logic tree approach. For example, if you want to study a megatrust earthquake with a magnitude of 9, but with a rupture really minor, that's not the best result for this model. It's not accurate, the magnitude with the rupture. So we have an error in the input of the logic tree approach. But I think the relevant here are the error and the tolerance of data and the tolerance of meters. And that is because if you can see this picture, we can see the deformation report for the 1906 event. And for this event, we can take qualitative and quantitative data. And the error is that we can discard one of the 40 models, but also if we are here in Concepción, for example, we can move the slip at 0.5 meters. So this has a error on our synthetic and our models. For the 7030 earthquake also, we don't have so much information about the deformation data. So we use only qualitative data, and we can discard 2 of the 6 models that we have of the information of uplift or subsidence. Okay, so regarding that, we have all the historical reconstruction of these historical earthquakes. So now we are going to try to focus on the interactions between the Marga-Marga fault and the subduction earthquakes. So for this, I'm going to try to use first the autocolumn method. This method assesses to see the displacement for a 3D strained field. Also, we help us to calculate the stress change, multiplying the strength with elastic tension. We can also analyze the aftershock distribution to try to assess the potential of future activations of the Marga-Marga fault. And this method is used before in figure 18. You can see in panel A the scenario of this autocolumn method for the 7030 earthquake. And if you can see, there are some possible activations in red of the fault for this major earthquake, right? And also we can see the column stresses for the 1985 event. And you can see that the point of activation are really minor considered the 7030 earthquake. So for trying to create these models, we need like an input, the slip distribution. And these models are good, but we are going to make is input my slip distribution for this research to reconstruct these autocolumn results. Finally, we are going to see the stress transmission simulation using the detector-saw method by Thompson. And for this, we are going to first need to a geometry with a mesh of the subduction zones and the cortical, the crustal fault that you can see in these figures. And we need the number of nodes of the triangles, the material and frictional properties, and the boundary conditions varying with depth. So this is relevant because this method also are going to show us the slip and deformations and the stress change, but with a more realistic view. And we have some preliminary results about this regarding to the historical earthquakes. First, we have some results to the 7030 earthquake with a magnitude estimate of 9.1 of moment magnitude. For this model, we have a total number of slip of 8,000, but only 9 passed the restrictions. You can see in this picture the 3 best models for that. And if you can see, it's really accurate with the research of Carvajal and Stuart, for example, that show us a really major earthquake with a shallow rupture, and the slip coincides with the deformation data. Also, this is important, but I don't see, if you can see, the slip distributions is really nearly to the 20 meters for this major earthquake. and it's relevant if are going to expecting an earthquake with similar characteristics for the future for this segment. Sorry, I'm going to fix some water. Also, we have some preliminary results about the 1906 earthquake with an estimated magnitude of 8. The total number of sleep models was 2,000, and only 4 passed the restrictions. Again, you can see the 3 best models for that. And this is a really good result because if you can see the sleep path is really good located between the deformation data of the uplift of the ghost. Of course, the sleep was minor because this was a minor earthquake, but it's also interesting because now in the present we don't have the sleep distribution for these historical earthquakes, so it's something a little new. Regarding the 1985 event, they are still in process because I don't have the deformation data, but it's processing up here. And also we have some preliminary results about the microseismicity of the Marga-Marga fault using the detector SAUR program, right? This is really good because you can see in these simulations the interaction between the Marga-Marga fault for entire seismic cycle. But we are going to try to do is see this vibration or deformation of the fault, but for a co-seismic period, like for example, of the 70-30 earthquake, to try to see some realistic form to the vibration and the interaction between the crustal fault and the subduction earthquakes. So, the preliminary discussions. First, for the 70-30 earthquake, the results present for this event are really consistent with the previous research of Carvajal and Stewart, which characterized this alert and shallow event. And you can see this in that proposed rupture for the 70-30 event by Carvajal. We don't have a lot of information about this model, but are really accurate, the result of our models and the model of the Carvajal. Next, for the sleep distribution of the 1906 event, this corresponds to a deep rupture, as outlined again, the Matias Carvajal, which will account for the structural damage in the Viña del Mar zone, because this uplift in the coast. And finally, about the interactions between the events and the Marga-Marga fault, we could say that there could be some form of relationship between the 1906 subduction event and the crustal fault if we consider that the damage in the localities are really nearly to the fault. So we have to research more about, like for example, see the historical accelerograms to try to quantify these possible reactivations of the fault and doing the out-of-balloon method for the 1906 event to try to see some influences of zones or some patterns for this. So possible mechanisms for that at first that the fault zones with the rock may have captured, respond to, and concentrate the seismic energy of the historical earthquake and propagating outward from the subduction earthquake and accelerating the local taking for the localities. But also, I think that the most important of these are the second point that say that the sediments associated with hilly historical ruptures constitute a weak sock in the fault, producing this activity in the fault of the surrounding area and triggered by those historical earthquakes. And this is a great point because we are going to try to study or try to understand also how is the influence of the sediments in these earthquakes. So, some preliminary conclusion. appears that the results suggest that akin to 1906 earthquake, a deep fault rupture is most likely explanation for the observed coastal uplift and the minor tsunami. Also, while a shallow rupture such as the 7030 megatons earthquake will account for the lack of coastal deformation, but will result in larger floods in the cities and a major tsunami. Also, based on the current level of coupling in the seismic gap of the Valparaiso region that show us in the one of the, I think that 3 figure, and the model results that indicate a deficit of shallow energy in the segment. So I don't say that the earthquake for the event in the segment are going to stay like the 7030 earthquake. But in some moment, this energy have to be released. So we can consider a future possible earthquake with similar characteristics for this historical earthquake, right? Taking account the coupling. And also to either confirm or refute our hypothesis, we must reconstruct the seismic history of Central Chile ourselves to try to understand the specific condition under which stress transmissions between the subduction and crustal events may occur, right? Because we know we have the historical part, but now we have to do the research for the interaction of the fault. And finally, that the reconstruction of historical seismic events, such as the 7030 and 1906 earthquake in Chile, provides crucial data for obtaining a slip distribution. And why is that? Because with this slip distribution, we can input this data to try to simulate this change of the stress between the crustal fault and the historical earthquakes. So we have the first part. And what are the next steps for this project? Well, first I have to this thesis defense. After that, and hopefully I'm going to the EGO conference in Vienna, and I'm doing an internship at Geofísica to try to research maybe the mechanics of influence of these crustal faults around the world, or try to study the influence of the sediment or the geology of these cities and the earthquakes. But regarding the models, I have to do some improvement to the model, right? And finish the model for the 1985. And with that, okay, I'm going to send, that is in process of writing, our first paper that talk about only the historical reconstructions of these megatons earthquakes of 2013, 1906, and 1985. After that, we are going to research only the stress transmission and the dectosaur simulation to try to evaluate the stress between these two faults. And also, if we have some time, we are going to make that the synthetic accelerograms to the events like 1906 and 1985, because these events maybe reactivate the crustal fault. So to finish this project presentation, I'm going to give you this takeaway message from Robert Thorson. Thorson is the geology that studied this Viña del Mar and Valparaiso segment, and also the Marga-Marga crustal fault. And he said that the burden of proof should rest with those who interpret the fault as incapable of surface rupture, rather than with those who interpret as active. So I just think of that. The reference and the acknowledgement, and this part I'm going to say that in Spanish, if you excuse me.